In this video, we're going to learn about glaciers and specifically what glaciers are and how they can contribute to erosion and deposition across the surface of the Earth. Just to start off looking at this picture of a glacier, it's a large body of ice that is located over land. You can have glaciers that are on the continent, which are continental glaciers. You can have glaciers that are located within the mountains, which are known as alpine glaciers. But either way, glaciers are large masses of ice that have formed over a long period of time due to repeated snowfall. I'm very proud of this particular lesson. I wish I can show you guys in person because this is the first time that I actually have my own pictures that I can show you of the environment. My trip to Alaska last summer allowed me to see many different types of glaciers and the features that they leave behind, and anything with a camera icon on the slides means that I took that particular picture, so yes, I am very proud. Here is one glacier from Juneau, Alaska, the Mendenhall Glacier. I didn't get a chance to touch the glacier, but this is a picture from the distance. This is an example of an alpine glacier showing the glacier within the mountains. Now this is an example of the Marjorie Glacier in Glacier Bay in Alaska. This was a beautiful glacier that I was able to get up close to. I couldn't touch the glacier here, but I was able to look at a distance from the ship that I was on, and it's just a beautiful sight to see. Here's an example of a glacier from Glacier Bay National Park in Alaska. Within this particular bay, there's different types of glaciers that are named after different colleges. Here's an example of another glacier in that park. They called this one the inverted skunk because, as you can see, most of the glacier is white, but you have that stripe of black that goes down the middle, so it's like an inverted skunk's tail. Another example of a glacier in Glacier Bay National Park. And here we have the Harvard Glacier. It's one of the most spectacular and largest glaciers in Glacier Bay National Park. So our ship fortunately stopped here for a long period of time where we were able to look at this glacier for a long period of time, and it's absolutely spectacular. Now here is me actually standing on top of a glacier, the Matanuska Glacier in Alaska. This was the last day of my trip and I was finally able to get onto a glacier. So here's my little thought bubble. I walked on a glacier. I'm very proud. Here's another view of me walking onto that glacier. It was cool. Ha! Get it? Glacier, ice, cool. Very funny. But this brings us to the process of erosion. How can glaciers actually relate to erosion, the transport of sediments, and ultimately deposition, the dropping of sediments? What you don't realize is that glaciers actually move. They move downhill. Over time, as the glacier develops and accumulates more snow and ice, the glacier grows in size and it actually moves downhill in that direction. And this video that I'm about to show you is a time lapse, so it's something sped up over a course of a long period of time to show you that these glaciers do in fact move. And when the glaciers move, they carry all the sediment that it comes across. So as a glacier is moving downhill, any rock, sediment, beneath the glacier is going to become part of the glacier and get carried with that specific glacier. So as you can see over time, you can see the movement of this glacier downhill, down the slope. But what you don't see is beneath this ice, the rocks and sediment are getting carried with that glacier over time. So this is an example of erosion. It takes a long period of time, but it's still erosion because sediments are getting transported along with that glacier. So this is what you can get as a result. In the background, you can see the glaciers and the mountain, but here in the forefront of the picture, you don't see any glaciers. That's because the glacier stopped moving and it's gone back into the mountains. When a glacier stops moving and it's no longer advancing, the sediments that it picked up and carried along the way get dropped, just like you see here in this picture. The glacier has gone back, but right in the area in the front of the picture, there's no more glacier. All you see is the leftover sediments that formed. These are called moraines, the pile of sediment that's left over by the glacier. So you can see here that pile of sediments left by that glacier. That's the best example of a moraine. Now, when I was in the Matanuska Glacier, I had the wonderful opportunity to stand on the moraine of that glacier. So right here, you can see that I'm no longer on the glacier. I am on the moraine specifically. And something you need to note about the glacier moraines is it leaves behind unsorted sediments. So if you remember with wind and water erosion, you get sediments that are sorted by size. That means they're organized, they're deposited in size order. When a glacier deposits sediments, just like with gravity erosion, the sediments are all unsorted. There's no organization or arrangement to them. It's a giant mess. So today, when you're doing your Freyer diagrams, moraine is one of the features that you're going to write down, and one of the biggest things that you need to know is it's a pile of unsorted sediments left by a glacier. Now, you have two different features that are kind of related to each other. Once a glacier stops moving and drops its sediments, it creates a moraine. But what we don't think about is the glacier is made up of ice. And when a glacier stops moving, it's often because the glacier is starting to melt. It's no longer able to grow in size. It's not able to accumulate snow and ice. So the meltwater from the glacier can take some of the sediments from the moraine and pushes that out a little bit further, creating something called an outwash plain. So take a look. In this diagram, we have two moraines. That's an unsorted pile of sediments left by the glacier. But those sediments can be carried because of the glacial meltwater to form outwash plains. So now we have two different types of features that can be left behind by a glacier. Outwash plain is going to be one of those features that you put into your Freyer diagrams. The most important thing that we need to know for outwash plains is that since water is taking over the transport of sediments, these sediments do become sorted. So what happens is the sediments in the moraine are unsorted, but sediments that become part of the outwash plain because of the glacial meltwater, they become sorted over time. So we have this discrepancy. Just remember, when water is involved, the sediments become sorted. If the glacier was involved with the moraine, the sediments are unsorted. So that's the most important thing that we need to make sure we remember. So here's an example that I'm going to show you. You might not know this, but all of Long Island was formed by a glacier. We would not exist on Long Island without glaciers and their advancement. And in this image, we're looking at two different moraines and outwash plains. All the way on the north shore of Long Island, you have the Harbor Hill moraine. A little bit south of that, you have the outwash plain. Then you have another moraine called the Ronkonkoma moraine. And just south of that, you have another outwash plain. If we focus in on line E to F, that spans north and south across Long Island, I want you to take a look at what this looks like. So if you remember when we made topographic profiles, it showed how the land looked like in terms of is the land showing a hill or a valley. In this case, I want you guys to focus on lines E to F. From E to F as a cross-section, you start with the Harbor Hill moraine, which is a pile of unsorted sediments, and then it brings you to an outwash plain. If you keep going a little further south, you get to the Ronkonkoma moraine, a different moraine, and then that also has an outwash plain. So over time, these moraines can get pushed out into outwash plains because of the glacial meltwater. So in some instances, you have hilly land with unsorted piles of sediments, while just further south, you have outwash plains with sorted sediments. So another thing that you might not have known is about 21,000 years ago, a lot of North America was covered by a glacier. We call this time period the last glacial maximum. So a lot of the land that we are accustomed to was once covered by glaciers. And this is part of the reason why the landmass of Long Island was formed. So I'm going to show you this little animation that goes through the formation of Long Island. I want you to notice right now in the blue, that's the open Atlantic Ocean where Long Island is now, but you can see 90 to 70,000 years ago that it did not exist. So at one point, a glacier came through and it stopped right there and dropped its sediments. And that formed the Ronkonkoma moraine, a pile of sediments left by a glacier. The Ronkonkoma moraine formed first, with unsorted sediments. But over time, the outwash plain developed from the glacial meltwater, which pushed some of that moraine further out. And then the glacier went away. Long Island is not completely done yet. That's because it took 2 glaciers to make Long Island. So the glacier came through, dropped its sediments, and it created the Harbor Hill Moraine. The outwash plain got pushed further out to fill in the gaps to create Long Island. Now, if you're familiar with Long Island, you'll notice that something is missing. On the bottom, which just showed up, those are the barrier islands. So if you remember from wave action, barrier islands form due to the erosion and deposition from ocean waves. So those barrier islands were created because of wave action, not because of the glacier, while majority of Long Island, as you just saw, was created because of that glacier. Now, glaciers leave a lot of evidence that they once existed over the land. Due to climate change, a lot of the glaciers that once spanned across North America are no longer in existence, but the evidence for them is there. So here's an example of a U-shaped valley. This is very different from river erosion when we told you that rivers make V-shaped valleys. Glaciers leave behind U-shaped valleys. So when you put these into your Freyer diagrams, you're going to really emphasize that the shape of the valley here is U, which is going to be important for glaciers. And if you look at additional information, I have a little bit of a trick for you. If you make the G really large, the bottom of the G kind of looks like a U, so that's your hint to remember that glaciers make U-shaped valleys, while rivers, that V in the word river, can help you remember that those are V-shaped valleys. More evidence that you can see scratches on rocks called striations. These are parallel scratches that you can see on the land. If you go to a lot of parks, you can see this, specifically Central Park in Manhattan has a lot of rocks with these parallel scratches called striations. And these are really important because they help us determine the direction that glaciers have been moving. That's going to be another feature that you put into your Freyer diagrams, striations. The big thing here is they tell us the direction a glacier was moving. U-shaped valleys cannot do that. Another piece of evidence for glaciers are these elongated hills called drumlins. Drumlins are a lot larger than sand dunes, but in terms of sketching a drumlin, they look very similar to sand dunes. So we have to be very careful that they are different. Drumlins are unsorted pile of sediments left behind by glaciers. And another thing about drumlins that's important is that they help us determine the direction that the glacier was moving. So if you look at a drumlin, one side of the drumlin is very steep. If you draw an arrow from that steep side towards the gentle side of the drumlin, you can see the direction that that drumlin was moving, which gives you evidence of how the glacier moved over time. This is going to be a feature that you put into your Freyer diagrams. So the key to the sketch that I included is the direction of glacier movement, because drumlins also provide evidence, just like striations, of how a glacier has moved over time. Another piece of glacial evidence are lakes specifically called kettle lakes. Where I'm from, Lake Ronkonkoma is a lake that is actually a kettle lake. If you remember the Ronkonkoma moraine, one of the pile of sediments left behind a glacier that formed Long Island, Lake Ronkonkoma gets its name because it's on that moraine, and it's a lake that formed specifically because of the glacial ice. So what happens is when a glacier leaves, chunks of ice can be left behind on the land. But over time, as sediments start to go on top of the melted block of ice, it creates this ice block that's encompassed with all these loose sediments. But over time, that ice is going to continue to melt, and it's going to form a lake, specifically a kettle lake. That's going to be another feature that you put into your Freyer diagrams here. There's no piece of additional information I need you to know, but I do need you to understand the stages of kettle lake formation as shown by the picture. Now finally, I don't give you any notes on this today. It's just more of something that I want you to know. There's a last piece of glacial evidence called an erratic. If you look in this picture, something is not right. You have a large boulder that seems completely out of place. The only explanation for this large out-of-place boulder is it was brought by a glacier. Glaciers are large and strong enough to carry all different types of sediments. A wind or water, like a river, cannot transport a boulder, but a glacier can. So if you see a boulder randomly in the middle of the open land, that's going to be your clue that a glacier brought that item there, because there's no other explanation for it. So at this point, I wanted to say thank you all for watching, because I'm not sure that all the students are watching these videos all the time, so I appreciate that. So hello from Mr. Chan and I from Alaska. And if you did not watch, all I have to say is not nice. Good luck on today's assignment.